Hello friends, today we are going to study a new concept. It is called the remainder theorem. And the remainder theorem says that if px is any polynomial, if p of x is any polynomial in x, and it is divided by, it is this polynomial, whatever this is divided by x minus a, then the remainder, it says, then remainder is the polynomial which is p of a, and this is what the remainder theorem says. And p of x could be any polynomial. It could be ax plus b, or it could be ax squared plus bx plus c. It could be any polynomial. When it is divided by x minus a, the remainder is always p of a. Now look at a few examples. Okay, it says if the remainder theorem holds true, now I'm switching to the question here. If the remainder theorem holds true, that is p of x divided by x minus a gives the remainder of p of a, then find when p of x is equal to x squared minus 2x plus 1 is divided by x minus 2. So you see, if p of x is equal to x squared minus 2x plus 1 is divided by x minus 2, my a is equal to 2, then p of a is equal to p of 2, which will be equal to, you see, p of 2 is equal to 2 square minus 2 into 2 plus 1. So p of 2 will be 4 minus 4 plus 1, which is equal to 1. So what this says is, if p of x is equal to x squared minus 2x plus 1 is divided by x minus 2, remainder is 1, and this is the solution. Now look at something very interesting in this expression. Okay, we know that p of x here is x squared minus 2x plus 1, and this is equal to x minus 1 the whole square. Now if I divide p of x with x minus 1, I know that the remainder is equal to 0, because x minus 1 is a factor of x minus 1 whole square. Agreed? So let me check what is the value of p of 1. Okay, if x minus 1 divides p of x, then p of 1 should be equal to 0, which is what I know here beforehand. So let's put that p of x is equal to x squared minus 2x plus 1. So p of 1 becomes 1 squared minus 2 into 1 plus 1. And this, my friends, is 1 minus 2 plus 1, which is equal to 0. This is what we were trying or aiming for. You see, when I divided this expression p of x with x minus 2, I kept p of a equal to p of 2, and the remainder was 1, which I received here. When I divided it by x minus 1, I found it by doing p of 1, and p of 1 is equal to 0. That tells me that it divides perfectly. So x minus 1 must be a factor of p of x. I hope this part is clear. If this is clear, let's shift our focus to another question. If the remainder theorem is clear to us, then we should be able to solve this question really fast. Let's see now. So it says find the remainder when p of x is equal to x squared plus 3x squared plus 3, I think this is x cubed. This should be x cubed here. It should be x cubed. Is divided by 3x is divided by x plus 1. So to solve for question A, I have to put p equal to minus 1. Remember this very, very well. It is x minus a. So the x plus 1 becomes x minus of a. Okay, and you have to solve for this minus of a here. So p of minus 1 becomes minus 1 cube plus 3 into minus 1 squared plus 3 into minus 1 plus 1, and this is equal to minus of 1 plus of 3 plus minus of 3 and plus of 1. So this one cancels this one and 3 cancels 3. This is equal to 0. Having a 0 for p equal to minus 1 means that x plus 1 perfectly divides p of x, and remainder is equal to 0, which we received here. The second question onwards I'll be slightly faster, so let's see here. Question B. So p of x is equal to x cubed plus 3x squared plus 3 of x plus 1, and x minus half, so I have to find p of half. This will be equal to half cube plus 3 into half square plus 3 half plus 1, which will be equal to 1 by 8 plus 3 by 4 plus 3 by 2 plus 1, and this will be equal to 8. This will be 1 plus 3 2s are 6 plus 4 3s are 12 plus 8. This is 27 by 8. This is the remainder. Let's solve the next one, which is x. So C p of x is equal to x cubed plus 3x squared plus 3x plus 1 is divided by x, and when it is just x, it means it is x minus 0. So I will actually find p of 0, which will be equal to 0 plus 0 plus 0 plus 1, and that's equal to 1, and this one is the remainder. I hope this part is clear to you. So I divided p of x by x, which means the divisor is actually x minus 0, which is usually x minus a. The value of a here is 0, and that's why I have put p of a as p of 0. Let's solve a question D. The D says, again, let me first write this down. P of x is equal to x cubed plus 3x squared plus 3x plus 1, and this time my question is divide this by x plus pi. So I will divide by x plus pi, which is equal to x minus pi, which means my a is equal to minus of pi. So I will put that minus of pi here. So p of a, which is the remainder, will be equal to p of minus pi, and that becomes minus pi cube plus 3 pi square plus 3 pi. This will be minus 3 pi, and this will be plus 1. So this becomes minus of pi cube plus 3 pi square minus 3 pi plus 1. This is the remainder here, my friends, for question number D. Now let's go to the final part of the question, which is 5 plus 2x. So this is slightly tricky. It says p of x is equal to x cubed plus 3x squared plus 3x plus 1 is divided by 5 plus 2x divided by 5 plus 2x. This means that 5 plus 2x is equal to 0, which means that x is equal to minus of 5 by 2, and the remainder a is equal to minus of 5 by 2, and p of a is equal to p of minus of 5 by 2, which is equal to minus of 5 by 2 the whole cube plus 3 times of minus of 5 by 2 the whole square plus 3 times of minus of 5 by 2 plus 1. This will be equal to minus of 125 by 8 plus 75 by 4 plus this will be minus 15 by 2 plus 1. If I take the LCM overall as 8, I get minus 125 plus 150 minus of 60 plus of 8, and this is equal to 125. I am left with 25 here, 25, and 8 is 33, and 60 minus 33 is minus of 27 by 8. This is the remainder. I hope you find this video useful. I really hope you find this video useful. Do like, share, comment, and subscribe. And I'm asking you to subscribe so that you receive proactive notifications of all my videos. And do let me know if there is a question from the syllabus of class 9 to 12 that you want me to solve by mentioning it in the comment box or messaging it to me over the WhatsApp number mentioned in the description box. Till then, God bless and cheers.